All right, chapter 3.5 has to do with complex numbers, and complex numbers start with the imaginary unit. Remember, I is equal to the square root of -1. That allows us to factor that annoying negative out of radicals. And also remember, the square root of -1 squared is just -1. So a complex number has an imaginary part and a real part, such as 3 minus 4i. So the real part's 3, the imaginary part is -4i. Okay, we're going to practice simplifying negative square roots, and I'm going to show the steps for the first one. So I'm going to factor out that -1, I'm going to call it I, there's the square root of 25, and the -1 goes to I, the square root of 25 goes to 5. But once we make a negative square root look like a variable, it's got to be treated like a variable. So we write it as 5i. That way the 5 doesn't get interpreted as an exponent. Okay, same idea with the negative square root of -98. Look, the negative is going to turn into I right away, and then I have the square root of 49 times the square root of 2. So I'm just factoring out the perfect squares. That gives me 7i times 7 times square root of 2. I'm going to write that 7 times I times square root of 2. Okay, so that's just practice in working with it. They also really emphasize how I works with exponents. So here, the first one, we're looking at I to the third. Now, remember, I squared is equal to -1. So this is just I squared times I, or -1 times I, or -I. So every time you have I to an exponent, it's going to be either a negative I or a positive I. It depends on the sign of the exponent. Here, this is I to the 30th power. Another way to think of this is I squared all to the 15th power, okay? Because 2 times 15 is 30. So I squared is -1 to the 15th power. That's going to give me, so first of all, I goes away completely. -1 to the 15th power is just -1. So you're going to get either I, or 1, or -1. Same idea here, -I to the 12th. This is going to be -I squared to the, let me try that again. I'm just using the properties of exponents to kind of do my thinking. -I squared, right the first time, all to the 6th power. Okay, -I squared. All right, -I squared, that's negative times a negative is a positive. I squared is a -1, so this gives me a -1 to the 6th power, and a -1 to the 6th power is just a positive 1. Weird little problems, but they do have several of them in the quiz. All right, find the following products. They're asking us to expand out these exponents. And let's take a look at 2 plus I, and I'm going to write it to the 3rd power. Or write that 3rd power expanded out. 2 plus I, can't seem to write it right. Okay, I'm going to square this binomial, so that's 4, and that's 2i plus another 2i plus 4i plus I squared. Look for I squared. It always turns into a -1. I need a little more room. So this gives me 2 plus I times 4 plus 4i, but that I squared turns into a -1. So it's 4 plus a -1, so I get a 3 plus 4i. And now I'm going to do the same thing. 2 times 3 is 6. I get an 8i plus another 3i plus 4i squared. That's going to go to 6 plus 8i, 6 plus 11i plus 4 times negative 1. So ultimately that will go to 6 minus 4, or 2 plus 11i. And I think this is the point to these problems, that what you need, no matter how many times you multiply, you'll always get a complex number out of multiplying complex numbers. Same with division. Okay, here's what I want you to do with B. I want you to try it on your own and then come back and check your answer. I'm going to pause the video while I do the work. Okay, my final answer on 3B was negative 107 plus 198. I am showing some of the work above. If you disagree with my solutions, come see me. All right, I'm going to stop this video and we'll start up on the next one.